When selecting a conductor size for a continuous load, it's crucial to adhere to the National Electrical Code, or NEC, requirements and consider the temperature rating of the conductor's insulation. The NEC mandates that the ampacity, or current carrying capacity, of a conductor must be based on the temperature rating of its insulation. This insulation is designed to withstand a specific maximum temperature, and exceeding this limit can lead to insulation degradation, posing a fire hazard. In the given scenario, we have a 104 amps continuous load protected by a 150 amps breaker. The task is to determine the appropriate conductor size. The NEC provides ampacity tables, typically found in NEC Table 310.16, that list conductor ampacities at different temperature ratings, such as 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius. The question revolves around which temperature column to use to determine the correct wire gauge. While the question doesn't explicitly state the insulation temperature rating, it is common practice for general-purpose wiring to utilize conductors with a 75 degrees Celsius insulation rating. Therefore, you should refer to the 75 degrees Celsius column in the ampacity table. Now, let's consider the specific requirements. The load is 104 amps continuous. According to NEC section 210.19, 8.1, branch circuit conductor shall have an allowable ampacity not less than 125% of the continuous load. Therefore, the conductor needs to handle at least 104 amps multiplied by 1.25, which equals 130 amps. Looking at the 75 degrees Celsius column in NEC table 310.16, you need to find a conductor that has an ampacity of at least 130 amps. A 1 American wire gauge, or AUG, conductor in the 75 degrees Celsius column typically has an ampacity of around 130 amps, depending on the specific insulation type and table used. A 2 AWG conductor might have a lower ampacity in the 75 degrees Celsius column. Therefore, a 1 AWG conductor is the correct choice based on the 75 degrees Celsius column. If you were to incorrectly choose the 90 degrees Celsius column, you might find that a smaller conductor, such as a 2 AWG, appears to have sufficient ampacity. However, this would be a violation of the NEC if the conductor's insulation is only rated for 75 degrees Celsius, or if the termination points are only rated for 75 degrees Celsius. It's essential to remember that the lowest temperature rating among the conductor, terminations, and devices in the circuit dictates the ampacity you must use. In this case, the 150 amps breaker protects the conductor from overcurrent. However, the conductor must still be sized to handle the continuous load plus the 25% requirement, which is 130 amps. The 150 amps breaker only comes into play if the current exceeds that level, providing protection against short circuits and overloads. To reiterate, firstly, determine the continuous load. Secondly, multiply the continuous load by 1.25 to account for the NEC requirement. Thirdly, identify the correct temperature rating of the conductor insulation, typically 75 degrees Celsius for general purpose wiring. Fourthly, consult the appropriate ampacity table, such as NEC table 310.16, and find a conductor size with an ampacity equal to or greater than the calculated value. And fifthly, ensure that the conductor size is adequate for the given application and is protected by an appropriately sized overcurrent device, such as a circuit breaker. Always consult the latest edition of the NEC and seek guidance from a qualified electrician to ensure compliance with all applicable codes and standards. Choosing the correct conductor size is critical for electrical safety and preventing potential hazards. Overloading a conductor can lead to overheating, insulation damage, and even fires. Therefore, it is vital to follow the NEC guidelines and consider all relevant factors when selecting conductors for any electrical installation. Different insulation types have different temperature ratings. Common insulation types include THHN, THWN, THW, and XHHW. Each of these has different properties and temperature ratings. THHN is a common type that is typically rated for 90 degrees Celsius in dry locations but may have a lower rating in wet locations. THWN is another common type that is rated for 75 degrees Celsius in wet locations and 90 degrees Celsius in dry locations. THW is rated for 75 degrees Celsius in both wet and dry locations. XHHW is a high-temperature insulation type that is typically rated for 90 degrees Celsius in both wet and dry locations. The temperature rating of the conductor must be suitable for the application and the environment in which it will be installed. For example, if a conductor is installed in a hot environment, it will need to have a higher temperature rating than if it is installed in a cool environment. In addition to the temperature rating of the conductor, it is also important to consider the temperature rating of the terminations. Terminations are the points where the conductor is connected to other electrical equipment such as circuit breakers, switches, and receptacles. The terminations must be rated for the same temperature as the conductor or higher. If the terminations are not rated for the same temperature as the conductor, they could overheat and fail. This could lead to a fire. It is also important to consider the dirting factors that may apply to the conductor. Dirting factors are factors that reduce the ampacity of a conductor. Dirting factors may be required for conductors that are installed in conduit, in close proximity to other conductors, or in hot environments. The dirting factors must be applied to the ampacity of the conductor before the conductor size is selected. For example, if a conductor is installed in conduit with 3 other conductors, the ampacity of the conductor must be dirted by 20%. This means that the conductor will only be able to carry 80% of its rated ampacity. The dirting factors are typically found in NEC Table 310.15. E3. It is important to consult the NEC and other applicable codes and standards to determine the correct dirting factors for the specific application. Choosing the correct conductor size is critical for electrical safety. Overloading a conductor can lead to overheating, insulation damage, and even fires. Therefore, it is vital to follow the NEC guidelines and consider all relevant factors when selecting conductors for any electrical installation. The NEC provides guidance on how to select the correct conductor size for a variety of applications. The NEC also provides guidance on how to protect conductors from overcurrent. Overcurrent protection is typically provided by circuit breakers or fuses. Circuit breakers and fuses are designed to trip or blow when the current in a circuit exceeds a certain level. This protects the conductors from overheating and potential damage. The size of the circuit breaker or fuse must be appropriate for the size of the conductor. If the circuit breaker or fuse is too large, it will not protect the conductor from overcurrent. If the circuit breaker or fuse is too small, it will trip or blow unnecessarily. The NEC provides guidance on how to select the correct size circuit breaker or fuse for a given conductor size. In addition to overcurrent protection, conductors must also be protected from physical damage. Conductors can be damaged by impact, abrasion, and other physical hazards. Conductors can be protected from physical damage by installing them in conduit, cable trays, or other protective enclosures. The type of protection required will depend on the application and the environment in which the conductor is installed. Firstly, calculate the minimum ampacity required for the continuous load. This is done by multiplying the continuous load by 1.25 as per NEC requirements. Secondly, determine the appropriate temperature rating for the conductor insulation. For general purpose wiring, 75 degrees Celsius is often used, but it's crucial to verify the insulation type and its rating. Thirdly, consult the NEC ampacity tables, specifically Table 310.16, and locate the column corresponding to the chosen temperature rating, such as 75 degrees Celsius. Fourthly, find a conductor size in that column with an ampacity equal to or greater than the calculated minimum ampacity. This ensures the conductor can safely handle the continuous load. Fifthly, verify that the selected conductor size is adequately protected by the overcurrent protection device, such as a circuit breaker. The breaker's rating should not exceed the conductor's ampacity, but it should be sufficient to handle the starting currents of any connected equipment. Remember that other factors can influence conductor ampacity, such as the number of current-carrying conductors in a raceway or cable, ambient temperature, and the presence of harmonics. These factors may require directing the conductor's ampacity, which means reducing its allowable current carrying capacity. Always consult the latest edition of the NEC and seek guidance from a qualified electrician for specific applications and to ensure compliance with all applicable codes and regulations. The consequences of using undersized conductors can be severe, including overheating, insulation failure, fire hazards, and equipment damage. Therefore, it's essential to prioritize safety and accuracy when selecting conductor sizes. The NEC provides a comprehensive set of rules and guidelines to ensure the safe and reliable operation of electrical systems. By following these guidelines and consulting with qualified professionals, you can minimize the risk of electrical hazards and ensure the longevity of your electrical installations.